Hello and welcome to a new video on IGCSE Classified Physics Paper 2. In this video, we shall be discussing the concept of thermistors. Thermistors are devices that depend on temperature. So as the temperature increases, the resistance of a thermistor decreases. So there is an inverse relation between temperature and resistance in the case of thermistors. So let's begin to answer questions. We'll start with conceptual questions. P and Q are the circuit symbols for two electrical components. Which components are represented by P and by Q? This is the circuit symbol for a thermistor. So for P, it is A or B. And for Q, this is the circuit symbol of a fuse. So we can cross this out as well. And the correct choice would be choice A. A computer engineer wants the speed of a fan to increase automatically when the temperature inside the computer rises. The engineer knows that a larger current causes the fan to turn more quickly. So we want something to link to a change in temperature when the temperature rises. So which device is dependent on temperature? The only device that we know of that depends on temperature is the thermistor. So choice B here would be the correct choice. The student sets up this circuit. What is the purpose of the circuit? So like we said before, this is the circuit symbol for a thermistor. And the purpose here has to do with temperature. So the only choice that mentions temperature is choice D, because a thermistor has nothing to do with light and dark, or the sound, or dimmer or brighter. None of these have anything to do with the thermistor. Just for your information, this is achieved using what we call a variable resistor, because this controls the current and therefore controls the brightening or dimming of a lamp. To amplify the sound of a voice, this is an electronic device like a microphone, for example, or whatever, or a loudspeaker. Microphone plus loudspeaker, maybe. To light a lamp in the dark, here for C, we would need something called LDR, light dependent resistor, and this is the subject of another video. However, the only device that depends on temperature, as we mentioned previously, is the thermistor. And from the circuit, we know that this is the circuit symbol of a thermistor. So therefore, D here is the correct choice. Which circuit contains a thermistor and a heater? So of course, this is an LDR. This is LDR. This is a variable resistor. Anyway, so neither one of these is a thermistor. Again, this is a variable resistor. This is a heater. So C and D are the ones that contain a thermistor, because this guy here is a thermistor. And they want a heater as well. So the correct choice would be choice D. So D is the correct choice. Now we move on to questions that have to do with circuit analysis of thermistors. A thermistor is connected in series with a sensitive ammeter and a battery. Which change will give a larger ammeter reading? So there are two relations that we need to be aware of. For thermistor, temperature increase implies resistance decrease. And another relation we need to be aware of is V equals IR. And this gives us three relationships. As V increases, I increases, or vice versa. These are directly proportional. As V increases, R increases. Again, these are directly proportional. And as I increases, R decreases. These are inversely proportional. We don't really care about this one. We just care about the relationship of R and V and the relationship of R and I. So since here they're talking about an ammeter, so we are concerned with the relation that says that as R increases, I decreases, and vice versa. As R decreases, I increases. So we're going to use one of these to solve this problem. Now, they're asking about a change that would give a larger ammeter reading. So I needs to increase. And this implies to us that R needs to decrease. And then for R to decrease, since R and temperature are inversely proportional, so the temperature needs to increase. So we want a choice that has to do with heating because we want the temperature to increase. So to summarize, we need three relations to solve any question on thermistors: temperature and resistance. As temperature increases, resistance decreases. Current and resistance also have an inverse relation. Voltage and resistance have a direct relation. These are the three relations that you need to know in order to solve the remaining questions in this video. Temperature and resistance are inversely proportional. Current and resistance are inversely proportional. Voltage and resistance are directly proportional. So in this question, the correct answer is C, heating the thermistor. A source of constant EMF is connected. There is an electric current. The temperature is reduced, which shows what happens to the resistance and what happens to the current. So here we start with temperature, right? So temperature decreases. What does this imply? We said that the resistance is the inverse of temperature. So the resistance increases. And current is the inverse of resistance. So the current decreases. So the correct choice here would be choice A. Components X and Y can be inserted to complete the circuit below. The completed circuit is a potential divider in which the potential difference across Y increases when the temperature increases. Which row shows the components of X and Y? So this is a bit tricky. We want to put something in Y so that the potential difference increases when the temperature increases, right? So let's analyze this. What happens when the temperature increases? When the temperature increases, the resistance decreases for the thermistor. So this is for the thermistor. As the temperature increases, the resistance decreases. And as the resistance decreases, the voltage or the potential difference decreases. So we want an arrangement so that the potential difference increases when the temperature increases. So obviously I cannot put a thermistor in Y, because if I put a thermistor in Y, what will happen is as the temperature increases, the voltage decreases, as you can see what I wrote on the screen. So the thermistor cannot be in Y. So what happens then? We have to put the thermistor in X so that when the temperature increases, the V in X decreases. When the V in X decreases, then the V in Y increases. So you have to put the thermistor here in X rather than Y. So therefore, the correct choice here would be choice D. So the difference between, of course, we know that A and B are wrong because we're looking for something that involves the thermistor because it has to react to temperature, not light. But is it C or D? So where should I place each component? Should I place the thermistor in X and the resistor in Y or vice versa? It depends upon the relation that they want. They want temperature increase to result in voltage increase. So I just need to compare this to what should normally happen if I use a thermistor. If I use a thermistor, when the temperature increases, the voltage decreases. So I cannot measure the voltage across the thermistor itself. I have to measure the voltage across component, the other component. So therefore, if the voltmeter is measuring Y, I need to put the thermistor in X, not Y. So the correct choice is D. The diagram shows a circuit used to switch on a heater when the temperature drops below a certain value. Now, in order for this circuit to work, when the temperature decreases, the heater is switched on. So for the heater to switch on, this is what we call a relay. We will discuss it in greater detail in another video. But for the circuit to work, I need the voltage to increase in Y. So the voltage needs to pass a certain threshold or a certain value in order to operate the circuit on the right. So I'm looking for something where as the temperature decreases, the voltage increases. So my question is, do I put the thermistor in X or in Y? In this case, we want temperature and voltage to have opposite relationships. So let's discuss what happens when the temperature decreases. This is for the case of the thermistor, right? So for the thermistor, when the temperature decreases, the resistance increases, and therefore the voltage increases. So the thermistor has the relationship that I would ideally like to see. When the temperature decreases, the voltage increases. So I need to put the thermistor where I'm required to increase the voltage. So I need to put the thermistor in Y. This is the idea. And in X, I'm just going to put a regular resistor. So therefore, we go for choice B, where we put the thermistor in Y and the resistor in X. The diagram shows a circuit with a fixed resistor connected in series with a thermistor and an ammeter. Which row shows how a temperature change affects the resistance of the thermistor and the current in the circuit? So let's write them down. For temperature increase, resistance decreases, and the current is opposite to the resistance, so it increases. For temperature decrease, the resistance increases and the current decreases because the resistance is opposite to the temperature and the current is opposite to the resistance. So we need to find a choice where the temperature is opposite to the resistance and the resistance is opposite to the current. Or in other words, the temperature and the current are the same, but the resistance is different. So temperature and current are the same, does not apply here. It applies in B. It applies in C as well. No, excuse me. Yeah, so for temperature and current to be the same, it does not apply in C. My mistake, I'm sorry. Because here we have decreases and decreases. But this is wrong, and this is wrong as well. Here, temperature and current are the same as well. So which is it? Is it D or B? Other than the temperature and current being the same, we want the resistance to be different. So this is correct, but this is wrong. So we have to go with choice B. As the temperature decreases, the resistance increases and the current decreases, which is what we wrote right here. The diagram shows a circuit which statement describes and explains how the circuit behaves. We want something that links the ammeter reading to temperature or light intensity. Of course, it has nothing to do with light intensity here because we have a thermistor, so we're only concerned with temperature. But what happens? What is the relation between the current and the temperature? Like we said, if temperature increases, the resistance decreases, so the current increases. So the temperature and the current follow the same pattern. If the temperature decreases, the resistance increases and the current decreases, but again, they follow the same pattern. So we're looking for something where the current and the temperature are the same. Of course, here we have increases and decreases, but here we have decreases and decreases. So the correct choice here would be choice B. The circuit diagram shows a fixed resistor R and a thermistor T used in a potential divider circuit. VR and VT are the potential differences across R and T respectively. What happens to VR and VT as the temperature of the thermistor decreases? Right, so we want the voltage, the effect on the voltage when we decrease the temperature. So when the temperature decreases, the resistance increases and the voltage increases. This is in accordance to the thermistor. So for the thermistor, when the temperature decreases, the voltage increases. So for T, since here the temperature decreases, we expect the voltage to increase. So I'm going to cross out these two choices. And what happens to VR? Remember, this is a potential divider circuit. So we have like 6 volts, for example, here. So if VT increases, VR must decrease and vice versa. So we're looking for something that features an opposite effect for VR and VT. So obviously this is choice A. When VT increases, VR decreases. The circuit shown is used to change the voltage as the temperature of device X changes. Which row is correct? The name of this type of circuit, this is called a potential divider circuit. And the name of device X is a thermistor. So the correct choice here would be choice B, potential divider circuit and thermistor. And this brings us to the end of our video. I hope this was useful. Thank you for watching.